IN2STEMPO, innovative solutions in smart energy metering. Smart metering is the mapping of energy flows within the railway system to measure consumption of traction and non-traction systems such as traction substations, depots and maintenance facilities. The general principle of smart metering is to collect measurements from trains and substations facilitated by gateways to a data management platform. The data is then processed and analysed in order to feed user applications for operators and infrastructure managers. Currently, energy data is not sufficiently monitored and managed proactively, resulting in increased usage and inefficiencies. The measurement of energy relies on, for example, tariff metering, which only samples at 30-minute intervals in the UK, which may not present a complete picture of energy peaks. Smart metering aims at building a standard and open architecture, coordinating onboard and ground measurements to provide detailed energy data analytics required to better understand energy flows in the railway network. The IN2STEMPO smart metering trials are conducted in 3 use cases: the commercial line operation and electrical infrastructure monitoring, both implemented in the UK, and stationing and maintenance operation, implemented in Spain.
Smart metering is equipment to collect data from our assets, to monitor or to transmit information that helps the operation and management of the railway system.
In terms of improving asset management, within the IN2STEMPO project, we've demonstrated how smart metering can be used for fault detection within the catenary system. Our novel approach is using Hilbert transform to calculate the phase shift. As a result, we can get accurate impedance calculation for catenary events. We can get online and automatic triggers to detect and calculate event parameters for the catenary.
The sensors measure parameters like voltage and current, and that also helps us see power consumption. The smart metering was installed in 3 feeder stations: Bushy Station, Camden and Acton Lane. We were trying to have a better understanding of our network's power flow, how our network's behaving. For Bushy Station, I've worked on making the main dashboard to get a good summary of what has been happening and try to get the data to come up quite quickly so you can see the data for the past 30 days, 2 months. There's not a lot of lag for it to load.
So the equipment is simple. We've got the current sensor, which is a Rogowski coil wrapped around the feeder cables. And then we've got connections to the voltage measurements, which are simple plug-in terminals. And then within the main panel, we've got the data logger.
This proof of concept, we explored fault detection. We've set up triggers to trigger at certain points, and that helped us get high sampling frequency data of those events. What's good about that is that we don't send high sampling frequency data all the time because it will overload the system and it'll be too much data. So we've set the triggers to only send 10 kHz data at interesting events or events we want to see at that frequency.
You can zoom into that event and show you the primary parameters or what the current was or what the voltage was. It's open platform. You can actually be able to implement tools to manipulate the data to suit what the user requires instead of a rigid system. This is very flexible.
With respect to monitoring and managing demand, we've used smart metering in IN2STEMPO project to work on regenerative braking quantification using machine learning. This novel approach allows us to detect regenerative current braking using only infrastructure data and is an accurate method to estimate energy recovery. It allows us, for example, locating sweet spots for energy recovery, storage and energy management investments. The main benefits that our solution can offer is the fact that our smart meters are non-intrusive, they are portable, and we can customize them for specific requirements of any end user.
It's live information. You can actually send detailed information without requiring huge infrastructure investment. It was using normal mobile networks.
The data collected from these 3 sites will allow implementation of user applications and ultimately the creation of a railway-dedicated distribution energy resource management system, which can be used to enhance the management of railway infrastructure.